right. This video is going to discuss the data analysis for the snowball fight that we did. So this is a lead up to the video on dynamic equilibrium, which is due Wednesday. What I've done is I have just copied the table that Gabe put. So I've just copied the table that Gabe copied down in class. And so as you can see, at 0 seconds, we had 150 snowballs on side A and 0 snowballs on side B. At 30 seconds, we had 76 snowballs on side A and 74 snowballs on side B, and so forth. So remember, side A is the one with all the people. And side B was just the one with the 3 people. So the one with more people, the side with more people, started with all the snowballs. And as you can see, the side with most of the people ended up with fewer snowballs because they had a higher number of people to throw the snowballs. So I'm going to make a graph now of the snowballs on side A, which I'm going to graph in red, and the snowballs on side B, and we're going to graph that as a function of time. So I'm going to start with side A. At 0 seconds, there were 150 snowballs on side A. At 30 seconds, there were 76. So I'm going to do 76 is somewhere almost halfway between 60 and 90. So I'm just going to do like there. And then 60 seconds, we had 21. So that's probably 2/3 of the way up here. So I'm just going to do, let's see, that's 30, so there. And then 15, which is exactly halfway up for 90 seconds. 120 seconds is 7, which is probably going to be like that there. And then we have 11, which is pretty much for seconds. So, to connect the dots there, the snowballs on side A kind of show this exponential decay function. Then, let's do the snowballs on side B, and we'll do that in blue. So they started with no snowballs. There were only 3 of them. At 30 seconds, they had basically the same number as side A. At 60 seconds, they had 129, which I think is going to be probably here. At 90 seconds, they had 143, so even further up. And then they had 143, which is very close to 150, and then that last one. So the side B snowballs looked kind of like this. So as you can see, the side A snowballs are rapidly increasing at the beginning. So the side A snowballs, we started with none, and then people start pelting them with snowballs. So on side B, they keep getting more and more snowballs because side A is throwing the snowballs at them. Side B snowballs are decreasing rapidly because side A, at this point, has all the snowballs and they have more people, so they're throwing them really quickly. Then what ends up happening is side A starts running out of snowballs. So if you were on side A, you probably noticed that you probably started throwing the snowballs less quickly. There were less snowballs available to be thrown, so you had to run around and find them. So you got a little slower. At the same time, side B's innate talent started coming out. They started getting more snowballs available, and so they could start throwing them faster. And so as you see here, at the end of the day, the number of snowballs on each side remained constant. Okay? This state here is what we call a state of dynamic equilibrium. And that's the time when that's the dynamic equilibrium is the state when the number of snowballs on each side remains constant. Now, I want to go a little further into this state of dynamic equilibrium. I want to talk a little bit more about what's going on when we achieve this state of dynamic equilibrium. And I'm going to have to erase my board because I'm doing this in Word. So, at the state of dynamic equilibrium, the snowballs keep moving back and forth. So even though the numbers of snowballs remain constant, they kept moving back and forth. There were always more snowballs on side B than on side A, because there were less people, so less people to throw, so the snowballs started to accumulate on side B. But the number of snowballs on each side remained constant. They remained fairly steady. So if you look back up at the graph that you saw on the last page, the number of snowballs remained constant. So I'm going to ask you guys a question. Circle which of these statements is accurate. You're going to answer this question on your head puzzle. A. As time progresses, the students stop throwing snowballs until finally no snowballs pass from one side to the other. B. As time progresses, the number of snowballs on side A comes to equal the number of snowballs on side B. C. As time progresses, the rate of fire of snowballs from side A comes to equal the rate of fire of snowballs from side B. D. Side A always throws snowballs faster than side B. And to answer this question, I'm just going to draw a little doodle of our graph so that you can have that to refer to. But see what you think. The answer, we'll go through these one at a time. So the students don't stop throwing snowballs. The snowball fight was raging even as the numbers steadied out. So the answer can't be A. B says as time progresses, the number of snowballs on side A comes to equal the number of snowballs on side B. Well, clearly, as we can see here, there are more snowballs on side B than on side A. So it can't be B. C, as time progresses, the rate of fire of snowballs comes to equal the rate of fire on side A and side B. And D, side A always throws snowballs faster than side B. Well, if side A is throwing snowballs faster than side B, the number of snowballs on side B should keep going down. What we're really seeing is when the rate of fire equals. So for every snowball that's fired from side A to side B, another snowball is fired from side B to side A. So let's say I have some snowballs here, I have some snowballs here. Every snowball that gets fired over here, there's a snowball that gets fired over here. If the rate of fire is equal, and I had the advantage of standing back, and I think Gabe had the advantage of standing back, and seeing this happen, the rate of fire of snowballs was equal. There was a pile on side A, there was a pile on side B, or a pile on side B and a pile on side A, not as big on side A, but the rate of fire of snowballs equaled, from one side, equaled the rate of fire on the other side. The side with less people had more snowballs to throw, so they didn't have to hunt around. The side with more people had less snowballs to throw, so they had to hunt around to find them. So at that point, the rate of fire from one side to the other equaled the return rate of fire, and so therefore the number of snowballs on each side stayed the same, even though snowballs kept being exchanged. So the correct answer is C. Now finally, I want to ask you guys one more question. And the question is as follows. The question is, when the number of snowballs on each side reaches a constant value, this is known as dynamic equilibrium. Dynamic means changing, and equilibrium means balance. Explain how the snowballs on each side are both changing and balanced when we reach that state of dynamic equilibrium. Answer that question, and then proceed to the next video.